Hi, this is Sri from Techie Talks AI. This is our second video in our ROS2 Robot Operating System version 2 series. In last video, we have seen how easily we can use Docker to install the essentials of ROS2 without having to rely on a separate Ubuntu server, which is actually the best way forward. Our on-site maker lab that we have in Trivandrum, India, we use Ubuntu. We will see that. But for our demonstrations and testing and teaching, we can easily use Docker. Now, what if I told you that real robots don't just print hello world? They continuously publish sensor data, say temperature, battery voltage, LiDAR scans, every second. Today, we are going to build one of those sensor nodes from scratch. Like we saw yesterday, ROS2 architecture converts the entire robotic system into subsections called or subsystems called nodes, like microservices, independently focusing on one sensor or one activity, one motor, etc. And they are loosely coupled, so it can subscribe to topic and publish to topic, and all the subscribers get the published message. Okay, so it's a data distribution service. We saw DDS. So today we are going to build one of those sensor nodes from scratch. We will use Python for it. Subsequent episodes we will use C++. So again, in episode 1 we understood what ROS2 is, what DDS does. DDS stands for Data Distribution Service, and how nodes talk through topics. But we use demo nodes. Today, we build our own node, starting from scratch. And not just a hello world node, a realistic simulated temperature sensor. We will generate random temperature. Let's go. The name of the node is temperature_node. And the topic is /temperature. Our node will generate random temperature values, publish every second, and use a real ROS message type. And we will see how visually we can see the topic in arcvt_graph visualization tool and be inspectable from another terminal. This is how real sensors work. Okay, so let's come out of this. I will clear the screen. I have created a /ROS2_WS root folder, and inside this folder I have an SRC folder. You can ignore the rest of the folders, we'll clear them. Let me delete the other folders and we will see how those folders come. Okay, so these folders I am deleting. So we just have an SRC folder. Okay. Inside ROS2_WS, which is our workspace, just an empty folder that we have created, and inside that folder create an SRC folder. Now what we will do is we will create a package. We will create a Python package, and for that we will use amend_Python tool. ROS1 used catkin_make build tool, and ROS2 uses colcon build tool, and ROS1 used catkin build system, but ROS2 uses amend build system. That is all we need to know. So in order to work with Python packages, we will use amend_Python. Okay, so we are in the ROS2 workspace. There we have a folder SRC. We cd into that folder. If you see, it is empty. Okay. Now what we will do is we will create the package here, ROS2. Make sure that ROS2 command works. If not, you will need to execute the source command to adapt the path for ROS2 binaries. Okay, so ROS2 pkg for package, create, and build type amend underscore Python, amend underscore Python, and then give the name of the package that you want to create, temp sensor underscore pkg. Okay, it's saying recommended to use one of these licenses. We can ignore that for now. Now if you see the folder, you will notice that the current folder, it created another folder, temp underscore sensor package. So make sure that when you execute this ROS2 pkg create command, you should be in the src folder. Now if you look at the folder, you'll notice that it has created several files needed for this package. So the scaffolding has been created. And see that there is a setup.py as well there. And there is package.xml. These files we'll go through later. Our focus is to create the Python node that reads dummy temperatures and publishes to /temperature topic. What I'm going to do now is use VS Code. Okay, so here is VS Code. Okay, and here we have the files and folders created by the ROS2 package create command. Inside this folder, let's create our node file, and let me copy and paste the code. So details of this code, the syntax, etc., we will learn subsequently, because in this series our focus is to learn by doing it. So first we will execute the commands and see how it works, and then we will understand line by line. Okay, so here we have the temperature node class. Okay, so here this is the callback, self.publish underscore temperature will be called every 1 second. And how is it publishing? It is creating a random temperature between 20 and 35, and self.publisher underscore dot publish. Here we are adding the log line. This is the main function that gets called when you run this. Okay, so let's save this and see the commands needed to take this further. So coming back to this class, this super.init temperature underscore node, this registers this node with the data distribution service, and from that point onward this becomes discoverable. We need to do an important thing. In setup.py we need to add the entry point. Let me replace these lines with the entry points to run our package. See, temperature underscore sensor underscore package, temperature underscore node, colon main. So that is what gets, that is the entry point to our application. So without this, ROS2 cannot run the node. This registers our executable. You need to come to our workspace folder. You come out of the src folder and make sure that you don't have any other folder. Otherwise, you will need to execute the rm command. So the command is rm-fr build install and log, so that all build files are cleared. Now we will use callcon build. Okay, see, one package finished. Now if you see, those 3 folders have come. So callcon builds the package, install folder contains executable, and sourcing updates environment. Okay, so ROS2 run temperature underscore sensor underscore package, temperature underscore node, that is the name of the node. Okay, temperature sensor node started and it started publishing. See this? So this is the quickest demo of how to create your own node that reads temperature. Now from another terminal, so this is another terminal And from here, we will use ROS topic to echo. ROS2 topic echo and slash temperature. See, so this is where, see, 20.33.47, 31.95. So here it is showing 2 digits, and here it is higher precision. Now what we will do is, we will visualize this using RQT graph. So that is what RQT graph is. The, see here, temperature node, and it is publishing to this slash temperature topic. See this? But we cannot see the values. So for that, what we will need to do is, we will need to use another visualization tool. We will execute this command RQT standalone RQT topic. So this can show the topic messages in real time. Okay, so this is the screen. We have the temperature here. See this? Okay. See here, the value dynamically changing. Do you see this? 27.1, 28.30.17. So this desktop application can also show the topic values. So, but we are not going to create another node to read this. This is good enough for us to begin our journey, and this is to highlight that it is this easy for us to create a node and focus on reading a temperature value from a sensor using the GPIO pins available in your target edge system, and then use the node to publish it. So what actually happened when the node started, it registered with DDS, Data Distribution Service, announced the topic and message type. DDS broadcasted the availability, and subscriber discovered it. Communication established automatically. This is distributed robotics architecture. Today you learn how to create a ROS2 Python package, how to create a publisher, how to use message types, how to build and register executables, how DDS auto discovery works, how to inspect topics and graph. You didn't just run commands, you built a real sensor node. In the next episode, we'll replace this simulated temperature with a real Arduino and publish a real hardware data into ROS2. That is where software meets hardware. See you in episode 2. Stuck with tech? Overwhelmed by AI, cloud, or coding? Mentor Expert gives you personalized one-on-one help, step-by-step guidance, and instant clarity. Your solution starts here.